Hello, I'm audible?
Yes, you
Yes.
are.
Yes.
Okay, so very good morning all. Uh, I hope I'm audible to everyone, and then like quickly wanted to check if you guys can have access to the chat. Can everyone try the chat? Yeah, great. So I can see a lot of messages. Okay, so let's jump to the talk today. Thank you, first of all, thank you all, and welcome to the session, upgrading to Yocto. So this is a brief what we would like to discuss. So just to get to know about the company, I believe most of you knows Phytech. It's a 38 years old German company. We are into system on module manufacturers, platinum partners for TI and NXP. So if you see the semiconductor uh, uh, vertical. So you have the chip design and then chip manufacturing companies, chip manufacturing companies like SoC vendors like TI, NXP, Qualcomm, Intel, AMD. So below, so these chips are used to develop the products. So in legacy, the companies used to take these processors and start developing the chips, but now the chips are uh, the ARM SoCs or the architecture of the cores are developed so fast. The technology transition is so fast that like now the people want to upgrade every year with the latest technology or like every couple of years. So it's difficult to do R&D on the SoC level. That's how the Phytech as a board vendors of the board partners comes into the picture. So we are a system on module manufacturers helping thousands of electronics companies to build their products, especially on the SBC side. So the uh, partners use Phytech SOM and build their single board computers, right? So we have a huge manufacturing line in Germany, and then in US and China and India, we work with contract manufacturing partners. So on this slide, if you see, this is our new campus. On the right side, you have the manufacturing unit, and on the left side, this is our development unit. So on our manufacturing unit, we have a 7 SMT lines, 7 manufacturing lines, where in which we produce all our system on modules. And then the second one is more about the test setup and test automation. And the third one, for a very selective customers, we also do complete end product box building also. So this was our recent last year uh, gathering at Germany. just to speak some numbers, basically, so now we are more than 12,000 customers worldwide, and then like many of the customers projects we have supported. So these like, so you can see 50%, more than 50% of the projects were supported by FiTech development team. So we have a huge team in India uh, for providing development services. So mainly we design and develop the carrier boards, and then we help them with the BSP support. So why FiTech? So it's all about like when you need when your team is developing a product which has to go at least for 10 to 15 years or 20 years of product lifetime, and then like you want to leverage the maintenance of the product and the life cycle management, the complexity of the BSP upgrades. So there where the FiTech comes with uh, the support along with the SOM, right? Like, so when you are buying a FiTech SOM, so you also getting a reliable BSP. And then we maintain this product development for you for a longer time. So we support industrial, transportation and medical customers for decades. So this is a quick hardware product lines which we do support. So mainly our core business is SOM, but like the single board computers are the accelerators, and then like we have a industrial imaging vertical where we also do a camera module design and development. So last but not the least, but the software. So it's not only about the SOM hardware, but like we invest a lot on industrial grade BSP to support our customers for their reliable products. So these are a couple of business verticals. So this is an interesting slide for FiTech from FiTech India, where we do provide all starting from your product development to the system on core modules, manufacturing support, and also building your team. So we build our team in-house. So we started in 2012 with 5 people team members, and then today we are 100 plus in FiTech Bangalore. So 80% of them are the developers, and 20% we support on the business side for enabling our partners to build their products. So these again a quick view on our product engineering services. So we do the complete hardware design, software design, and manufacturing. Right, like so these are a couple of phases starting from specification, BOM selection, schematic, layout, and till your board bring up and BSP development and validation. Yeah, so let's jump to the session. Before we jump to the session, what I would like is basically, so if you guys can just ping in how many of us are developing embedded hardware. Can you quickly ping in yes if you are developing hardware? And then you can also write if you are developing hardware based on microcontroller or microprocessor, MCU or MPU. So please write MCU for microcontroller and write MPU for microprocessor, right? So by the time you guys key in your stuff, let me just there would be a lot of participants who are new to the hardware, or like they develop the software on a closed box, right? So let's give us a quick classifications of embedded systems. So with our 40 years of experience and then our product transition, so this is how, at least inside FiTech, we classify different types of embedded systems, right? So the first one is your system 1.0, which you can see over here, which is a microcontroller based. So these are the small embedded systems or the products where like they have a specific task, right? Like say now you here for the simplicity, I have taken a wristband which sends your it would have a pulse oximeters sensor, and then like it sends your heartbeats basically, and then send the data to your mobile app. Either your mobile app can store locally or it send it to the cloud. And end of the day, anytime you can see the report in your mobile app, right? So here, if you really see, there would be a small microcontrollers, whether it is a 8-bit till 32-bit microcontrollers, now with secure cores, without secure cores, and there are like a very high-end microcontrollers, even which can clock up to 400 megahertz. So we would have, if you really see, so at least I can remember the days of 8051 microcontrollers, Atmel or Philips microcontrollers, which we started, and then we used to clock it at 24 megahertz or 30 megahertz, basically. So today you have similar kind of microcontrollers, which is ARM Cortex M0 or ARM Cortex M0 Plus, which is the smallest, low cost, low power microcontrollers, which are used for your battery powered devices or IoT sensing devices, basically. So those all things comes under System 1.0. So this System 1.0 are the microcontroller based devices which are meant for a specific task. And I believe you guys are able to key in your what you are using, MCU or MPU, basically, right? So this is what System 1.0. Mostly you write a bare metal code uh, on this with your business logic, but most of the time also nowadays you also start using a couple of RTOSes. So if you guys are aware of some RTOSes, can you please key in the RTOS which you are using? So the RTOSes which at least in the industry right now more popular are free RTOS, and then the upcoming one is the Zephyr, which is a Linux Foundation one. Um, and legacy ones, if you really look, there were RTOS like Contiki or Micrium OS. So these are the RTOSes which were commercially available, and there are a lot of other vendor specific, right? Like say SysBIOS was by TI, NQX by NXP. So these are some of the small RTOSes which were available for System 1.0 or for your microcontrollers. Now the second one, if you really see, so now you can see from us a wristband to a smartwatch. So you have transitioned from a wristband which will sense your heart rate or temperature, a couple of parameters, and send it using some wireless communication, and mostly it's BLE. But now if you really see, so you have migrated from a microcontroller based small device which do a specific task to a microprocessor based smart device, right? So here you can see feature phones. So the Nokia phones with the keypads you can put over here, right? And from an industrial perspective, all your DIOs, all your sensors, you can keep in this category System 1.0. Now from System 1.0, you are slowly migrating to System 2.0, which is more generic system, right? Like so now when I say generic system, so the need of your file system, the need of your network stack, the need of your USB stack, the need of many modern protocols, lot of software, the need of the database. So these kind of additional features slowly popping up in your system requirement when some of your software engineering team or the product development team from a software side. So they say, hey guys, now we need these features. And then slowly you start seeing that like there are a lot of software components, uh, high level software components, right? Now, specifically, if you ask me, the database, the file system, the networking stack or USB stack, your multimedia, audio. So now these things can be realized in a microcontroller, but like again, you need to spend a lot of time. And then like you the resources are limited, right? So that's how you jump from system 1.0 to the system 2.0, where your expectation is you need a computer like hardware, where you have an operating system and you focus only on developing your application or bringing in some stacks and then developing your application. So that's how system 2.0 comes, where you have a microprocessor based, and the bare minimal thing is your expectation is it comes with an operating system. And what you do is you develop multiple applications. So take a example of the smartwatch. You can check your emails. Now you can call from your smartwatch. You can message from your smartwatch. You can have multiple applications in your smartwatch, reminders, emails, and all those things, right? So that's how you have migrated from a microcontroller to a microprocessor, next gen, right? Now, what is that trending today? So today the trending is your artificial intelligence and machine learning, right? So now if you really see the MPU plus, the microprocessor plus is nothing but with your hardware accelerators. The hardware accelerator, which would have capability to run your artificial intelligence machine learning models on the device, and then do a lot of data analysis and a quick decision making actions, right? It's not only gathering the data, but it's also processing the data as per specific models or the specific algorithms, which are like your AI ML models, and then like help the device in the field itself to take a necessary actions, right? Like say, take a small example of your electric vehicle. So tomorrow when you are driving, you can sense the lot of sensors, send it to the cloud, and then like wait for the decision making from the cloud, right? Like, so you need something on the edge. So the edge computing is what your the system 3.0 systems which are built today, and then you have a lot of applications running around, right? So now how it differs from system 2.0, it's very simple. It brings in a lot of hardware accelerators and high computing, little bit of high computing, right? So, and it have these special hardwares like, so the AI accelerators are sometimes called as TPU, Tensor Processing Unit, VPU, Visual Processing Unit by Intel, GPU, Graphic Processing Unit by NVIDIA. So, and NPU, Neural Processing Unit. So you have multiple names of these accelerators by different guys. And then on top of this, you have a lot of edge computing. So now you can see, so you saw a wristband, a smartwatch, and a AI watch. So you can see over here, so it's not only the applications, but you have a lot of edge computing capabilities on your watch itself, right? So where it also makes instance decision by running processing the data available by with reference to some model which is available on the device, and help you to take the decision, right? So hopefully, so maybe then like now it's more clear for a couple of you guys, and then like whatever, if these slides help you to at least understand what you are using, MCU or MPU or MPU plus. So it would be great if you have keyed in the chat, right? So now, so the session was for Yocto, right? And then like why we are discussing more on the hardware. So the idea of this Yocto is to build your custom embedded Linux for your custom hardware, or you take a hardware for which you might not use all the functions of those hardware. You are using a specific functions of a given board and customizing your operating system. So now when you are customizing in your operating system, so the first decision making to to really understand your hardware, right? And then like configure the build system to build a custom Linux operating system image for your hardware. So I thought like a brief on the hardware introduction would help you, right? So if you see the pyramid of the hardware architecture, so it starts from your architecture, whether you take it as a x86 architecture or a ARM architecture, or like your uh, uh, now RISC-V architectures, right? Like, so using these architectures, you develop core, the CPU, the processor, right? And these processor are like a bare processor which do the computation, and they don't have the interfaces, right? Now when you develop a product, you need a lot of interfaces, lot of communication interfaces like GPIO, I2C, UART, SPI. So all these are special controllers, right? So which you put together with your core and come up with a SoC, right? So system on chip. System on chip is your processor today, like say IMX6UL or like AM335 5X from the TI, or like Atmel A5G2 uh, by Microchip, or STM32 MP15 or MP13 by ST, MSM8909 by Qualcomm. So you might have a lot of chips which have been a core part of your any embedded system, right? Like, so these SoCs are now your processor plus a lot of interfaces, whether it is a communication interfaces or a display interfaces, or right, like, or a high speed communication interfaces like USB or Ethernet, or like say can interface for a lot of automotive, but now it's not limited for automotive. It's even widely used in building management, BMS, energy sector. It is widely used, right? So these all interfaces comes with your processor and make a chip. Now, so why do you need a SOM, or why do you need a SOM after a chip is basically, so the SoC cannot run a Linux operating system until it have a RAM, a flash, a power management IC. So these three basic components, if you add, it's like your CPU, right? When you want to assemble your computer, you buy a motherboard, you buy a processor. So this is like your processor, but along with processor, you buy RAM, and then you buy hard disk, and you buy SNPS. So at least these are the components which you have to buy to assemble your CPU. So similar to that, on along with SoC, so you add these devices to make a song. So you can see over here. So this is the processor, and these are the RAM. This is a flash eMMC, and this is the PMIC, and this is the Ethernet. So now this a small device, like you can see, is this little bit bigger one from us on the latest one. But if you see, we have 3 centimeter by 3 centimeter for IMX6UL or IMX9 or STM MP13 or a AM62 from TI. So we have a small system on modules which gives you all these required devices to run your operating system. So either you can call it as a computer on module, or you can call it as a system on module, or you can call it as a smart. So there are different names, but it's all the same. So the high-speed digital devices which are required to run your operating system. So you have. So this is the core of your embedded system, right? So which is system on module. Then you develop your motherboard, which is nothing but your single boot computer. So the single boot computer would have your all your interfaces specific to your application, and end of the day you add your software and hard enclosure, and you build a product. So if you see a small example, you want to build a gateway product, you need a motherboard. So if you see our website, you can get a 5-board Segin, which is based on 5-core IMX6UL system on module BIOS, and then like which have NXP IMX6UL as a SoC, and the core which is used is ARM Cortex A7, and the architecture, the ARM architecture which is used is ARM V7A. So now this is how you can correlate your hardware. So this would be your first step to really understand your customized hardware, so that like we can go to the next step of customizing the operating system for your custom hardware. Right. So a quick slide to give you the list of couple of SoC vendors, and then the SoCs which are available with them. So few points which I want to give you. So you can see a lot of SoCs, and then maybe they might be of same performance and the same things, and then you really get confused which one to use what. Okay, so let me give our experience, right? Like say now how these SoC companies have started their business, right? Okay, so now if you see the TI, NXP, Microchip, ST Microelectronics, or Renesas, so these are the companies which they have started with the core general embedded market, right? Like so when you want to do the automation, so how our electronics in the industry have started with the automation, with the need of automation, right? Okay, and then slowly is into different, like so the IT, and then like your now automotive in the defense space and all. But like the first automation term started from your industry, right? So like these are the vendors who develop these system, the SoCs, their chips specific to these industry needs, right? And then you saw an era of smartphones, right? Like now today there are there are many companies who are developing a chip for your smartphones. But if you want to give the big two names, then always you would look for Qualcomm or MediaTek. But now in last 3 4 years, you can see many other manufacturers for the smartphone chips, right? Smartphone processors, right? And then you have a tablet or a TV box kind of market, where you have Asian manufacturers like Amlogic or Allwinner, basically. And then like you have one more category of uh, SoC manufacturers like Broadcom or Athros. Athros is part of now Qualcomm. So these were more from a networking processor. So if I would classify as a industrial or general embedded, and then I would classify as a mobile market. I would classify as a tablet or consumer grade multimedia processors, basically, and the network processors. The one which I have not listed, example Broadcom or your Marvel, which are or Realtek. So these are the companies who develop network specific processors, right? So this is how you can categorize the vendors and look for some of your the chips available by them and map to your product. So these slides give you the next step of the SoC, the SOM. Using this SOM, you can develop your single board computer, which looks something like this, basically, where you pull out a lot of interfaces to connect all your external devices. So this would be your motherboard for your product. So the next is your product. So where you develop the software for this hardware, and then start putting into the casing, right? So now what next? Once I develop my single boot computer, right? Like, so I need the software. So let's try to unlock the software components, right? So now when you see these slides, so I have we tried to list you a couple of components, right? So now here the very first thing is the hardware. So we have discussed a couple of slides on the hardware. Now, the first software which runs on top of your hardware is your bootloader, right? The piece of code which is responsible to initialize your hardware and prepare the environment for your operating system. And the foremost today, any connected device, you need to upgrade the firmware, right? So if you really see the three functions because of which you need a small piece of software which should run before your operating system is called bootloader. And why you need a bootloader is for the hardware initialization, basic hardware initialization, preparation of preparation of environment for the operating system, any operating system, or today there is a lot of virtualization. So you have hypervisors, a lot of hypervisors to run parallel operating systems, right? Like we have a cool demos of hypervisors. So if your company is working on hypervisor and multiple OS, let us know. We can arrange a couple of demos using Zen or other jailhouse or kind of hypervisors on our latest hardware, right? So now on the bootloader, so this bootloader is responsible for your firmware update. Now you can't live without firmware update for your connected devices. So if you really see your phone, more or less, I think a month or so, within a month or so, you get some or the other update and you install on your in your mobile. So similar to that, the requirement, the security things, the functional changes or the customer requirements. So you cannot develop a one-time software and run it for decades, right? Like many of the times, these connected devices now they need a latest features or modifications. So that's how the firmware upgrade, which is one of the most critical functions which you want, is supported by your bootloader, right? For the operating system, I'm telling. So the application again, you can do it within your OS. The next core part of your operating system is your kernel, right? The Linux kernel, which essentially bring all your multi-threading, multi-processing, device management, memory management, all your basic functionality of your operating system is bought by a piece of code called kernel, right? In our case, we are using a Linux kernel, so you have uh, other operating systems like Windows or QNX from for the autos, right? Like so automotive. So earlier it was VxWorks now, but even VxWorks has started using Linux for their a commercial version of the Linux, which is mainly for the safety critical or machine critical operations, which are used in the real time applications like space or medical or any critical automation, right? So the second part is your Linux kernel, and the third part is your middleware and your application. So the middleware is in the form of libraries or binaries or services which run below your application, and these all are part of your root file system, right? And if you see the bootloader or Linux kernel or the root file system, all are codes, all are your C codes or C++ in your middleware or something like you have now different languages which can be supported, your C, Python, Node.js or Java, right? Like, so those are libraries. So now whatever it is basically, so you have the source code of it and you do customize and compile it. So that's how your tool chain, right? So these are a couple of building blocks of your embedded system, right? Which you should know. And this is what we are trying to build using build systems, right? Okay. So so on a high level, so after your hardware, you have a bootloader, the first component, kernel, second component, root file system, third component, right? But from on a Linux board, if you take, you have a bootloader, and you have a bootloader environment partition, Linux kernel device tree, which is your again a configuration for your hardware, so that like the Linux kernel can be generic for a family of your hardware. You need not to change the Linux kernel on runtime, basically. So at runtime only the device tree, you modify the device tree and you have configured for your second variant of your hardware, right? If it is of same processor. Okay, so then the third one is your root file system. So bootloader, Linux kernel, and root file system. So now let's see how these, now when you package everything and then you get a distribution. So now these are more low level components. And so now you have uh, the the next level is you package all those things and then put as a distribution, right? So now when you see when you see a Linux as an operating system, you would always, the first thing which you might have seen is a Ubuntu or a Red Hat or a CentOS basically, right? So then you might know the Android. So can so all can see the slide, the Linux OS distribution. Put it on the chat. Someone has said like the slides are not moving. Maybe like please. Okay. So maybe like the people who have the problem. So please restart, rejoin. That should solve your problem. Okay. So the questions. Fine. Okay, so we'll take some break and then I will give you those four questions. Okay. So now let's see the operating system. So now the Linux distributions. Now what you have seen is basically is mostly you might have seen Ubuntu or Red Hat, or like Android is well known for you guys, or like iOS, right? So now these are the distributions of your operating system. So now Tizen is by Samsung, Open Web OS is by LG, Chromium again supported by Google, Chrome OS, and then like Arch Linux is one of the distribution for embedded. Debian is the core distribution. Again, Ubuntu was derived from Debian basically. So these are kind of like a ready operating system. So now any other operating systems you are aware of, can you just key in the chat any other operating systems, Linux based operating systems which you see in the market or which you are working? Can you type any other operating systems in the chat which you have used? Yeah, Kali, Lynx, yeah, Fedora and Red Hat are the desktop, CentOS and all. So I have not listed many of the desktop versions, right? Like some of the versions which you see over here are also running on your embedded system. So that's how we have listed couple of, I would have said embedded Linux OS distribution. Okay, but these many of them, Ubuntu is a general purpose, but again, it is running on your mobile phone or it is running on your embedded, right? Okay, so now, so these all things are good, but like, what is this custom Linux, right? So now, how do you build a custom Linux or custom operating system? Okay, so now, or why do we need a custom operating system? If I'm a software developer, I would develop a application and I would take a box which would come with some operating system and I will just run my application. But if your company is an embedded product development company, then you would develop some board, some hardware, right? Like where you will customize the things as per your business needs. And then when you have customized the hardware, so there is a need of customizing the operating system so that you get the performance and optimization and the cost out of it, right? So that's how, or now the security needs, right? Like, so you don't want to depend on a ready-made stuff or the distributed stuff, right? So that's how you go for your customized Linux. So now how to customize your operating system. So for that, we have already explored what are the components of your operating system. And then now this custom Linux, let's see how to do that, right? Okay. So this custom Linux basically, so now for, if you ask me how to compile a bootloader, make dist clean, make board name underscore def config and make. So these are the three commands which you should know how to compile your bootloader, and the bootloader source code would be provided by your hardware vendor, right? Similar to the Linux kernel, again, make dist clean, make board name underscore def config, and then make uimage or make like that. Okay. So, okay. So, and then like you take some build system to build your root file system, right? Okay. So, so in Linux build system, if you try to explore Linux build system, so these are a couple of list of build systems using which you can compile your softwares, right? So the first software was your bootloader, second software was your Linux kernels, and the third software was your root file system. But this root file system, when you say this root file system, it's not a single software, but it is a kind of thousands of software packages, small packages, right? Like say your web server, your uh, MQTT library or a JPEG library or your machine vision library, right? Or curl or like any encryption library. So any software you see, your SQLite library, right? Okay. So now when you see this, your Qt library or like uh, what kind of function you need. So there are a lot of software. It's not a single software. Those are a lot of softwares and many software packages which you have to compile and bring it together and put it beneath above your Linux kernel, and then start developing your code by using these softwares, right? Which are like middleware or your stack, your stack or libraries, what you call, right? So now these things which are part of root file system, so it's not a single component. So that's how why these all build systems has evolved, right? So where they don't want you to struggle taking each component, but you take a build system and then configure the build system with some machine configurations, some hardware configurations, and it will download all those packages and build your root file system. So that's how these build systems has evolved, right? So you have CrossNG, Scratchbox, OpenWRT, PTX dist, Linux target image builder. Earlier it was by Freescale. Build root is still common, lightweight, smaller build system, very much popular for your building your root file system. Then the shift happened with Open Embedded, and then finally using OpenEmbedded, a Yocto project, right? So this is a project which is today we are talking and which has become a industry de facto. Industry de facto. Can I know how many of us are using already Yocto? So can you please ping in the chat? How many of us are using Yocto or want to use Yocto in the next project? So how many of are using Yocto and or even want to use Yocto project in next project, right? It's not only for the Linux, even for your free RDOS or something, you can now use Yocto. Even for your OpenWRT, if you are developing some network routers or network communication devices, now 5G is in big boom, right? Like so, so you can compile different operating systems also using Yocto. Slowly it is expanding. Okay. So very few. Okay, fine. Okay, so let's see what are the basic functionalities of a build system, right? So because this will really help you what build system you are already using, and if any one of you are using any existing build system, please type in any other build system you other than Yocto you are using. You can write that also, right? So if you are using Yocto, or if you want to use Yocto, or if you are using any other build system, please type in the chat, right? Okay, so let's see what these build systems really do. So the very first thing, right? Like, so now if I want to install some software in my computer, or like if you want to add some package to your operating system for your board, right? Like, so you know that software, and that software could be a open source, or it could be a proprietary build at your company. So you have to get that source code, right? The fetch source. Fetch source is nothing but downloading the source code, or like copying the source code, right? Okay, so once the source code is copied, you have to extract it, right? It would be in the form of a tar, or it would be a git basically, and then the software which you have downloaded from a open source would be uh, kind of like a generic one, right? Like, so which will be a mainline version, or the main branch of the open source. Right now you have to put your hardware specific modifications, or your product feature specific modifications, right? So those modifications are distributed in the form of patch. So normally you maintain patches for any modifications which you would have done on top of any of open source uh, software, right? Okay, so what you do is you then now apply those modifications on your source code which you have extracted, right? And the process is called patch. So now what you have done, you have taken a base code and you have applied the modifications on that, right? Okay, so once you do modify, you configure it, right? Like, so now the with all your hardware configurations, you try to configure, and then like not only hardware, but like what kind of operating system you want to develop, what are the features of an operating system. So with those all features, network services or any other thing, so all with all those configurations, you configure it, and then you try to compile it, right? So once you compile, you get the binary, but you need to package it, right? If you want to uh, distribute that package, right? So now, how do we install some software in your Ubuntu or Red Hat, right? Like, so apt-get or yum install uh, RPM, right? Red Hat Package Manager, or deb for Debian, basically. IPK, if you have used Buildroot or any other embedded Linux distribution. So right, these are couple of package management modules which are available, right? And then that's how you can also compile. Once you compile, it's not only for your image, but you can also distribute these binaries for an existing system, so for which you may package it, right? And once you package, so either you can also put it on the server and it get installed, or like or you during your root file system or your image building, basically. So you copy that binaries to a specific location, which we call it as an installation, right? With some configurations and all, and then finally image creation. So these are the basic steps which happens on many software components, many software components. right? So, so this process happens on many. That's how your custom Linux operating system is built. So these kind of all activities need to be done, and it's not a single time activity. You have to download a lot of packages. So you can consider kernel also as one package or bootloader also as one package, right? So you have to do this process on many softwares to get your operating system, right? So I try to make some of these operating system comparisons, right? Okay, so you have a Yocto, you have a build root, you have an OpenEmbedded, you have an OpenWRT, you have a PTX dist, you have some Debian and Android. So some high level. Now, if you really see, first you need to understand what kind of product you are really developing, right? So now, depending on that, you need to choose if I'm developing a network-based device. Obviously, your choice would be a OpenWRT because a lot of networking services, lot of packages, a lot of security part which is required is already there, and then like your other players are already using it, right? Like now you can't go for something. Yes, you can develop your own, but like you need to spend that much of time, money on the customization of those things, right? So you need to look first what kind of product you are really developing, right? So according to that, you have to look into what you want to use, right? And then the next one is basically the flexibility, or like how you want to scale, or like what kind of configurations, or what is the next level of feature which is really available with your build system, so which help you to scale, which will help you to customize, right? Okay, and then foremost, so all these build systems are open source. So now what is the active engagement of the community is happening? So how active this is, how big it is, basically, right? Okay, and then finally, most of the time, yes, we want to start it, but it's very complex to start. It's having a longer learning curve, right? So now, but like end of the day, if you have a learning curve, but like still your product strategy, go to the market, okay, and then the product development which you are doing, you have to align with your market demand, right? Okay, so now this is one of the slide you can see, right? So the Yocto as a build system which was developed, it's not only by community, but like by also the participation of big industry giants. So this is one of the biggest factor you should know, right? So when because end of the day you would be using one or the other hardware, or you would be using one or the other operating system. You would be using one of the other software feature. So now this is how there is a huge contribution. Now, when you say Linux, today you can see that Linux is widely used. So whether you say your mobile phone, or your car, or your smart TV at a house, or any network device in your house, right? A Wi-Fi router or so. So anywhere if you see the big complex electronics, some or the other way they are using Linux operating system, right? So now the same way the Linux foundation, the Linux kernel is maintained not only by the community users, but also by the contribution of these industry, right? So how they contribute? They contribute in terms of funds, they contribute in terms of developers. So there would be a dedicated developers from each of these company who would contribute back to the community, right? So it's not only the hobby guys or the community guys who develop when they get the time, but it's also about a dedicated industry contribution which happens, right? So that's how Yocto could gain a position of industry de facto. So today, if you really see, if you want to build a customized Linux operating system for your product, so then your Yocto would be an industry de facto, right? So that's how like it goes on a longer term. So now similar to the Linux LTS, now you would see the LTS support by Yocto. So at least 2 years of at least minimum commitment is there, and then like the development is supported by many professional engineers around the globe, right? So I could see many of us have used either build root or Yocto. So a little bit many times we see we work on the projects where we have a customer with his existing build system as a build root, and then we have upgraded them to Yocto. Right. So for the developer community, I just want to get a little bit more in deep basically. So now when you say build root, so these were the simple make files, and then like made your task easy to take multiple packages and then compile them as a root file system. So the motto of the build root, the name itself is root. Root is nothing for root file system, right? So build your root file system. That was the motto of the build root project, right? And then it very well suffice, or like it very well justify that requirement. Until today, if you see, if I'm a embedded developer and then I want to quickly build some custom operating system or a hardware validation, and then I want to build a small quick Linux, I would still prefer a build root. Right. Okay. So so it is based on make, the build tool which you see is based on make. So Yocto was not with that a small requirement. Yocto was derived from OpenEmbedded. OpenEmbedded was itself a big complex project which wanted to give a lot of scalability and customization and a layered architecture. So that's how the Yocto has came. If you see the tools, make tool, and then like if you see the Yocto, it uses a BitBake, which is based on a Python, a tool written on Python, which is having many more features than make, but like both are like similar stuff. So and then when you see the architecture, so the build root have a lot of packages which you can download and configure and build it. Whereas Yocto, before the package, the layered architecture comes basically the SDK. So now it's not only compiling a custom Linux image for your target, but also what next developing an application, right? Like say now more and more products need to be developed using a base system. So now when you develop a system, you need a SDK, right? Typically what you do, you take a software, some package, you cross compile it and you copy the binary into your root file system. And now when you want to develop any application for the using the same package in your host, what you do, you set the path of the header files, you copy the library, or you point the ldlib variable to point out the cross compile library within your host. So you have to set those things. You have to go and modify into the make file, or at least on a command line, you have to pass your C flags or LD flags. These are the things which you have to do when you want to compile your application, which is using that library or that software, right? Okay, so so such kind of all things are now packaged and provided as a SDK. So now you can whatever components you have selected for your target to build a image are now packaged for your application development on the host also. That is what your SDK, right? So and then like package management, right? So the package management was one of the next level of enhancement happened where like now you can build your Debian based distribution, your customization, Raspbian and all what you are seeing, right? Like, so it is derived from Debian, right? Now, so they are customized operating systems and the package distributions where like ready, there is a group of people or developers who validate your package for a specific target and then upload it and redistribute it, right? Like, so you can download that already binaries. Or when you develop internally with your organization, you can also maintain a server and you can redistribute using the package management, and you have to enable the package management within your source. So typically at a development time, yes, we enable the package management for the embedded. Most of the time we, at least at a release level, we remove the package management. Build level, yes. Build level or development level, yes. So I hope we know that like when you compile your sources, you have a release and you have a debug. Now, when you say debug, you are making more modification. You want to debug the things and all, right? Similar way in embedded system, at least for the security reasons or so basically, so you avoid enabling package management. It's more for while development, the quick prototyping. Now you see now the world is so fast changing with IoT, AI, and all those things. So you don't have much time to do everything by yourself. So what you do is you try to find out a ready available package and then just install and go ahead, right? And later on you will take care how to customize that, right? Okay, so this is a couple of highlights which we wanted to highlight you. So now if you ask us what you will use, whether a build root or Yocto, basically, yes, of course, if I just want to validate my hardware quickly, and if I'm doing a hardware project, I'm not delivering any software, yes, still I would use build root. Or like if I have a project which I know the specific features, and then my team is very small and I can't expand, and then like so we know what to components, small number of components going into my custom embedded Linux. So still you can continue with build root. And then if you see that you want to catch up with the latest components of the software, you want to upgrade your the OS of your product with the market demands and the latest things basically. So you might to be forced to migrate to Yocto, right? Still any questions you feel, please keen. So we'll take 2-3 minutes in between, or I can say another 5 minutes or 10 minutes. We take break and then we continue a little bit deep into the Yocto. But before that, maybe like a couple of questions I would like to answer, and then like we can discuss if you have so far, if you have any questions on these things, whatever we have discussed. So maybe 10 minutes. So I am looking in my chat if I have any questions or still a confusion whether we any specific question regarding these build systems, right? Yes, Debian. So there was one question. Can we enable package manager which pull from Debian ARM64? Yes, you can you can do that. So the question was, you build your Yocto, and then now maybe some of the packages you want to pull it from the Debian distribution, right? The second question was, do Yocto support CMake build? Yes. So you have auto tools and CMake build things, and then you can write the BitBake. So maybe like in the next session, I would try to put those things. So Ashwinji, which is more useful compared to both? I think you are talking about build root or Yocto basically. So as I told, depending on your need, product need, or the kind of requirements, which market you are catering, and then the product nature. So if you are asking me, I want to develop the latest IoT applications, and then like I keep on upgrading, I need to address the security, I need to do the many things. So I believe you are forced to migrate to Yocto. Otherwise, always you can still live in build root. I'm starting a project on STMP13. So can you suggest me about software for Linux OS? Software for Linux OS is means like you want to use which build system? I believe better you follow the ST. I think ST is releasing Yocto. At least we release Yocto for our STM32 platform. You can see over here. So this is our STM32MP15, and this is the BSP development using Yocto. And similarly, we have for TI and NXP. Okay, so will you upgrade the rugged board repo to support the latest Yocto and Atmel bootloader? Yes. Will you show a basic project based on Yocto? So these all are our products already. We are using Yocto. So these are the simple commands from where you can see how can you build a Yocto. Yes, I have one slide where I can show you how can you build a Linux OS for your board. Is any security guidelines documents are available for security for embedded Linux from FiTech? Yes, we have security manuals. You can see how you can enable there are security components. So different platforms have different security modules in the SOC or so. So you need to follow your strategy, and these are a couple of components by default we are providing, using which you can build your custom Linux and enable the security on your device. BitBake build community is available, right? Yes. So BitBake is also an open source, and then continuous development is happening on BitBake. How to find a tool chain? So once you compile your Yocto, so you also get the tool chain, or if not, typically as a part of your vendor, from any vendor, if you are taking, so they can also distribute tool chain. So now for us, for example, in our cases, you can also get the tool chain. Mm, 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 mm. So when once you compile the Yocto, so in your build in your temp build folder, basically you would have that. And if not, like we generally upload the pre-compiled toolchain, which you can download. Or you can, if you are using any vendor, so ST or TI, they will also point out to some pre-built toolchain. Uttam, I'm unable to set up from STM32 platform. Maybe I need more information. Uttamji, you can write to us, or we can discuss after this call. Can we do pin muxing in Yocto? Basically, so in Yocto, you have uh, all the software packages are called recipes, and then you can see when what do you pin muxing is a small component basically within your Linux kernel. So one of the activity within the kernel. So you can modify the Linux kernel within the Yocto, and then pin muxing is also part of your kernel customization. So what you do is you modify the DTS file, right? And then once you modify manually, maybe like you can also then generate a patch out of those modification. Next time onwards, you can apply it as a patch. So any security for TI Vega board, so we have a custom one. So the TI chip had some encryption modules, and then TPM we have added for a couple of projects externally. So if you have any external TPM project, we can help you out. I will deploy an object detection model from a camera, mainly with the camera. Can you suggest a development board? Uttamji, so we have IMX8 and from TI AM62, so you can use them for the image processing. How to create BSP using Yocto? So it's a kind of a process. So we can teach you a little bit more detail in a Yocto. Couple of my videos are detailed in Yocto, so there I can tell you how to build a BSP meta layer. Pre-building Yocto, what are the manuals which you will suggest building for FiTech? Example, security manual, Yocto software release version. Some cases while building Yocto, we get a Git server issues branches. Yes. So Git server and branches issues mainly because of the servers. So most of the components which we take basically are from open source, right? And many times the open source link URI which we might have used while development or like while for distribution, some of the servers would have been not active. When they not get active, you get that problem. If you have such kind of errors, please raise the ticket. You need to send that issue to support@fitech.in, and then we would solve that. So we are responsible to solve that. IMX6UL or IMAX 8M series, which one is the best? Suresh, so it depends on your need. IMAX 6UL is the low cost, low power one. IMAX 8M is your Cortex. IMAX 6UL is Cortex A7 and IMAX 8 series is Cortex A53. So if you need more compute, you need to go with IMAX 8, but like you need depending your application, if Cortex A7 with 500 megahertz is sufficient. It depends on the software components what you are using. Many times, most of the industrial interfaces are same, right? So IMAX 8 might come up with some advanced features like display and video codecs, and then like audio encoders and all, basically only for the interfaces like UART, SPI and I2C. I think more or less both will give you a similar number of interfaces. So it's more about a compute power to compare between IMX 6UL and IMX 8M. Okay. So can we integrate HMI framework with RZ-A1H? Yes. We in Yocto. So I need to look Yocto. So we RZ-A1H is this platform we have supported. I think 2016, 17, something time like that. Basically, yes, we did supported Qt. At that time, Yocto was not the build system by Renesas, but now I think Renesas supports Yocto build system, and then you should get the UI framework. If it is not integrated, you can check. You can check with the Renesas team. We also closely work with Renesas team. So if any support required, we can provide you as a service, great service. Which communication protocol mostly used in embedded industry? So it's a very open question. Communication protocol in terms of when you say like each board to board, you have I2C and SPI from a device. In between devices, you have all these CAN, Ethernet, USB. For display, you have different other interfaces. So you need to specifically tell the use case so I can help you with the communication protocol. Currently using AM62, I want to do a screen mirror, how it is possible. Screen mirror, which UI you are, which graphic. So which graphic framework you are using, and then you have to look for the settings depending on the graphic library you need to take, or like in Wayland or the windowing manager, we need to look for some feature to mirror your screen, or or you have for your display, if you are using any TFT, and also there are hardware registers normally, so using which you can reverse or orient the rotation of the screens are possible. Which OS we are used and all in version, so all. The question is not very specific, so please, will you be explaining the cross-compiling mechanism as well? Just curious. Yes. If there is any pre-built images provided by your team. Yeah, so we provide pre-built images. You can download the images for most of our SBCs, and then you start. So you need not to really build any image to start your development. So we have single board computers for which. Is there a guide how to modify Yocto? Is there any guide on how to manage modifications to Yocto in company Git or Azure? So The question, if I understand, you are while development, you are doing the code modifications and then how to manage. Basically, I think you can get some tutorials, if any, in with us. We will share you basically. But the normal process, as I told, like, so after modifications, you can create a patches and then you have to modify, put it in your recipe file, your patch folder basically, and the recipe file will pick up, or like if you have listed the patch file names, you have to modify your BB file. Why do we use LCD interface was the next question. LVD. LVDS for interface for LCD, right? For display, you have the basic one is RGB, which is parallel. Then you have LVDS. Mainly when you want your screen size is above 7-inch, you need to pump more pixels, more data. So LVDS is differential pair. So where in RGB you are transmitting the parallel data. So the interference would be one of the key point which you can avoid in LVDS, and mainly for the bigger screens, right? And then you have a MIPI, and then you have HDMI, and then you have other VGA and other. So, but VGA is normally not a controller within the SoC. So there is always a translation. Can I given can EEPROM here information how to interface external module and the DTS configuration, etc. So this is I think you are asking for integration of any device like EEPROM or any external device over I2C or SPI. So there are other tutorials specific to it. So we can help you all. So okay, so let me quickly jump back to our other session, right? So little bit Yocto workflow. Let's now look a little bit deep into the Yocto. So now you decided to use Yocto, and then now you want to know a little bit inside the Yocto, how to use Yocto, what all things you need, right? Okay. So as we have seen the build, process of any build system. So like you have to fetch. You have to do the fetching of the source. You can fetch it from different sources, from the different servers, whether it is upstream, like your FTP, legacy one, or you're from local projects, basically. So you could have a local server where you have kept some tars or Git, right? So you have other SCMs, basically, in your organization using which you are using the source code management, basically versioning control, basically. So those things you can configure in your server fetch module, how to get these things, right? And then so all these gray and black things are like more what you want to give to this process, right? The fetching is the process, and for this process you need these components, right? And you want to provide the different configurations. So like, say if you want to download from a specific server, you need some login credentials and all those things. Those you need to pass it over here, right? So once it is fetched the source, then you are doing the patch. So for that, again, like you provide the meta files. So in any build system, you have the source code, and you need to do some operations. These are like operations, and how to do these operations, what need to be done in these operations. You provide the instruction using your metadata, right? So meta file. Okay, so so these are the inputs. Your recipe files or patch files would be the input to do the patch. Once this is patched, you go for the application configuration. and compilation. Once these all things are done, then like all your dependencies and all those things, and finally the packaging. Once packaging is done, so you can do also testing within Yocto. And then once all the things are tested, it is fed to the server. So this is the server where you can compile your packages and put it over here. So either it could go to a target or it can go to a application, right? So application SDK for the application development as a part of SDK. So as an output, you are generating an image for your target or you are generating SDK for your image. So this is the workflow of the Yocto. Now coming to the components of Yocto, if you see, so the Yocto have better. I use this slide. So the Yocto, as I told, the Yocto is derived from OpenEmbedded project. So the core of the Yocto is OpenEmbedded, OE core, right? On top of that, you have a reference project called Poky. So that Poky project has been developed as a part of Yocto, and there are a lot of reference BSPs have been added through Yocto, basically, right? And within the Yocto, then you start developing your hardware specific layers. And then apart from your hardware specific layers, you can use different middleware layers for like functionalities like your UI, security, internet connect, like your IoT, different. And then you can also have your own layers of vendor specific layers, basically, right? So this is how you develop. Now, if you see in the blocks, so you can see OpenEmbedded as the core part where you get all your basic recipes. In Yocto, you call each package as a recipe, each package, software package as a recipe, right? So you can download. So each recipe is responsible to handle one specific software package, basically. So you get a basic set of these recipes, and using this OpenEmbedded, the Poky as a reference, the Yocto project has been created, and then the BSP, added the BSP, right? So now you can see the Meta TI is your BSP layer and Meta QT is your UI layer. And then you can have your own custom layers. So all the layers will start with a meta hyphen, right? So meta. So just to quickly show you. Right, so these are the layers. These are the layers available, and then like a lot of packages. So now before layers, you should see the packages. Like say MQTT. Right? So now you can see the MQTT libraries which are provided by different open sources, the different variants of MQTT library, right? So those software packages has been tested. These are the versions. So you can go say Baho MQTT. I think mostly people use. Now you can see the home page, Eclipse, and the recipe file is this. And this is the version, right? Now, if I want to show you how it looks like, so this is the recipe file or BB file, BitBake file. So we will come back to this. I will explain you in detail, but you can see these are the packages which are meant, and these are the layers. So in order to compile your Yocto, you need OE core layer. I think you can see over here. Yeah. So normally you you take first the OE layer and the Poky and Yocto layer. So these are the default layers which you take, download, and so this one from the mainline, this from the mainline, and this. So sometimes these are two you download from the same GitHub. So you get these. So these are the meta-core or meta-OE, basically meta-Poky and meta-Yocto, or like you would see meta-Poky and inside that like meta-Yocto would be there. So these are the cores. Then you download your meta layers of the BSP. So these all are like kind of collection of packages, collection of softwares basically, and using this you compile your image. So let me just finish some components, right? So here if you see, okay, download is missing. Fine, no problem. So now let's try to understand the components of Yocto, right? So how this Yocto works. So now if you see, the first part of Yocto is your tool, which is used to compile your sources. The tool is nothing but your BitBake. So in your when you take a Linux kernel or when you take a bootloader, right? So you download the source code and then you need a toolchain basically, and then you use a make. So instead of make, now we are using BitBake. So BitBake is the tool which is written in Python, and then you are using this tool to compile using the toolchain. So this will tell how to compile, right? Like how to invoke your toolchain and put all the source codes and all the configuration flags. So normally, how do you generate a binary from a source? So you need the configuration flags, you need the source, you need the configuration, and you need the toolchain, right? Now in which sequence and what to do. So those all things need to be written as a process, like in make files. Normally you write in make files, right? So similar to that, so similar to make the BitBake, and then like for BitBake you write .bb file, which is you called a recipe, right? So in you write a recipe and then tell how to compile a software, where to take, download and configure whatever we have seen as a part of your build system functionalities, right? So those all things will happen. And the bit.bb file is what you would be writing. Now, apart from BB files, basically, so you would also be writing a configuration file, so where you will be putting all your flags for configuring your hardware, you're configuring, providing your the flags for your compilers, and then you want to like what kind of distribution you want to use, right? Like what kind of packaging you want to use. You want to generate a .rpm or .deb or .ipk, if any package manager you want to use. So those all configurations you can pass it, and these configurations can be configured in multiple layers or multiple components, right? So one configuration at your layer level, and the first is the recipe layer, mainly for your machine, for your hardware, which is nothing but your machine, and then image, and then distribution. So in these different levels, you can configure these configurations basically. So some are like available at multiple layers, and some are available only in couple of layers or couple of levels. So you have recipe level, you have a layer level, you have a machine level, you have image level, and you have a distribution level. So these 5 levels, you can configure your software and pass your configuration macros, basically, right? So, so you have a BB file and you have a .conf file. Then you also use, say, let's suppose some packages are doing a common functionality, right? In Makefile, like let's suppose you have developed a rule to download the software from your specific server. So you have written your own commands or the security logins, authentications, and all those things, right? So now you have to follow that same fetch function for all the recipes when you are doing within your from your server, basically, right? So the common tasks which are defined for compilation of your source code, instead of writing this common function within every BB file, you can write it in a class. So similar to your library, right? So any reusable functions, you will write it in a .bb class, and you can inherit it. So similar to your C++, you write a base class, and then you can inherit it when you are writing your recipe. Okay, so we can walk through couple of recipes, so you can look into that, basically. So this is the reusable code. So these are all the files which are telling the Yocto how to compile your source code, whatever the functionalities we have talked about. Sometimes what happens, I have already written a BB file to compile the bootloader, say barebox for my second board or Vega board, basically, right? Now I have some modifications, or I have some additional patch file, or like I have changed some modifications for my another board, custom board. So what you do, you instead of rewriting the BB file, so you will add those steps, what the modifications you have done, and you will rewrite the BB append file. So this is something like you do task 1 and you do extension of the task 1. So you are not rewriting the task 1, but you are just modifying some additional things within the task 1, basically, right? So the BB, so I should not say task. It's like for configuring or compile the software, you are modifying a small. So the best example is you already have a recipe for doing compiling one package, and you need a small modification. You don't want to change or make one more copy. So instead of copy, you can do the changes within your append file, basically. And layers is the group of your recipes. So this is how your Yocto is structured. So these, wherever you are seeing meta, it is a grouping, you can say directory. Wherever you are saying recipe, it is the collection of these files. You can see the recipe. Let me show you one of the recipe. So here you can see the recipe of barebox. So multiple barebox versions, basically, and you can see some of the include files, and then these are the configuration files, what we were talking about, right? And here I think you have the patch. So this is the patch file. So you have a patch file, you have a configuration file, and then you have a BB file. So BB file, if you open any BB file, you can see the location from where it has to fetch, the versions, and then like it have some tasks. Right? So these are the functions. So like in your make files, you have rules. here in BB file, you will define the tasks. You will define the tasks basically. Maybe some simple recipe I will try to see. So these are some classes where BB classes you can see which I am using. So let's suppose for IMX8 image creation, I have this is the specific one. So just you will use this BB class in your week. So week IMX8 helper BB class. Now you can see you can go to the week recipe and IMX8 SD images dot WKS. It's not using. Yeah, you can see over here. So some include, these are the include flags, sorry. Linux. Yeah, here is a BB append example you can see over here, 5.15. So you are adding the same. So with this BB file would be there. And then like you are adding this kernel package base name and DT overlay, Phytech DT overlay you are adding basically. So one of the tasks you are doing over here. So I'm not telling how to compile my main line. I'm compiling my main line with my Phytech DT overlays basically, right? So you can see it is like this is our common Linux kernel recipe with multiple boards. So these all are different board compatibility which are using AM335 SOM, right? So if you want to compile the Yocto, so you have to first download the Yocto, and then like you have to configure it for any board. So you have to open first you have to configure run the environment variables basically. So you have to initialize the environment for the Yocto using which source Poky OE and env build env. So this will initialize the Yocto build environments basically, and then it will create a build folder. Then you have to go to the build folder and change the conf local.conf your board file name. Once your board file name is changed, you can run BitBake command with image name. So this is image name basically. So different images would be available for Qt or different images would be available. So you can just give BitBake and image name. So once image is built, let's suppose you want to compile any other software. So BitBake the package name or the recipe name. Say like BitBake, whatever the recipe names we have seen in this layers, right? So you can give the recipe name and then it will compile, provided you have added that you have to see that like the step one, what you have to see is I can say MQTT client, BitBake MQTT client. But for that, what you have to do is which this MQTT client is provided by which layer you have to see. And then like layer you can see over here. So you have to include this layer. You have to include this layer in BB layers. So same, whatever the conf folder, you would have conf BB layers.conf. In that you have to add this layer. And after that, when you say BitBake this recipe name, it will compile. So likewise, now you can see that these many softwares are like it's more than I think 10,000, around 10,000 software packages are ready available. So many of them are multiple implementation of the same software. So MQTT is your software package, right? Now you have AWS MQTT, and then like you have PAHO MQTT, right? So you have a MQTT server as you have to MQTT client basically. So like this, you would have a lot of softwares which might be already integrated. So as I told, the configurations you have to do at a recipe layer, machine, and then image and distro. So this is how, like, you have a lot of tutorials at our website which you can go. So we have a BSP guide. So maybe I can help you out with one of that. So I'm Excitem Plus. Many of you guys have asked, you have asked for image processing. So this could be one of the good platform. So software manuals. So this is the Yocto manual. So I think this would be a good place to look for. So whatever we have discussed, so you can look in a lot of these all things, whatever we discussed, a lot of things has been documented by us. You can see how to use it, the commands and all. I can put it in the chat. Mostly, I think for everyone, the chat is accessible. And one of the BSP manual. So I think we could able to give you a short introduction of Yocto, but like the intention of this workshop was to really give the importance of Yocto, rather teaching deep into the Yocto. So introduction of the Yocto was there, and then you can find a couple of more videos in YouTube. Maybe we can share you as our technical sessions. These are a couple of extra slides. This is our SMT line in Germany. So this is a AM68, the very latest platform by TI. So where we have multi-object detection demo. So any of these demo you would like to see, please write to us. We would arrange a demo at your office or online. This is one of the EV charging reference demo. So that's all from my end. And then if you have some queries, we can still discuss for a couple of minutes. So please follow these manuals, Yocto reference manual and BSP manuals. I believe you should be able to do hands-on. So we are not able to do any hands-on in this session, but like request, you can send us a request or put on away here. Like we can arrange one more a small hands-on demo session on Yocto also. But for that we need from your side requests so that like we can pull out some of our developer to do so. Which Linux platform should I have to use the build Yocto? It's actually, I think the question is which host system. So Linux, preferably Ubuntu. Ubuntu Linux host is required to build, and then you should have enough RAM and a hard disk. We would not recommend VMware host. Yes, you can do, but like it depends what memory and how much hard disk and all. So it need, at least for the first time, you need a lot of time, compute power, right? Um, what is the minimum flash size required for Yocto? Flash size is more from the target side, basically. So in using Yocto, you can build the smallest image. The smallest image what we have built was 10 MB. So our team could able to build a 10 MB Linux image, which includes all your bootloader, kernel, root file system, and a little bit space. So we have our rugged board A5D2, which have 32 MB of flash. So core tiny minimal image is what you have to try for, Umesh ji, if you want to look for the smallest one. But like we have our hardwares, normally we have hardware with our NAND flash. So NAND flash, typically NAND flash, we use 128 MB or 256 MB and 512. So we have Linux images in hundreds of MBs basically. So like say below 200, around 100 MB and so. It depends what packages. So you support hardening for embedded Linux? Yes, that is by service. We do provide services for that. Yeah, we can arrange one small hands-on workshop. This was not supposed to be a hands-on workshop. It's more of enabling Yocto, because we don't know how many partners of us, or like how many embedded partners in the market are using Yocto, and how we can enable Yocto. So that was the idea, this tech talk. Which version of Ubuntu? Yeah, so LTS, Ubuntu LTS version you can take. Probably depending on you start with the version which was specified by your vendor. So if by Phytech we will tell which version we have tested, and you use that rather getting into bug fixing of the host dependencies. Yeah, Yocto, you can also use Docker. So we do use Dockers. NAND flash versus SD. SD card is a removable, NAND flash is a fixed flash, and then similar to SD, you have eMMC basically, which can be fixed, which can be a non-removable device basically, right? So you have uh, bigger. So NAND flash, again, like you can't go with bigger sizes. What right now in the market you have 16 GB, 32 GB, 64 GB and all. So for Android, sometimes you have to go with 32 GB, 64 GB. So eMMCs are more recommended, and NAND still you can use for the system images like your bootloader, kernel and all this. NAND or NAR you can use. SIM modem integration, yes, we have a lot of references for the modem integration. We integrate multiple modems. By default, we support Quictel modems, and then like we do have Sierra Wireless modem supported by default. So we also do integration of different Delete or Neoway, Sierra Wireless. So you can do. So thank you all. So please help us to reach your team. Please pass the information. We have a couple of more workshops coming up, mainly enabling the technologies and then the higher edge computing. So next workshop is edge computing uh, design. So how can you develop a edge computing hardware and system? So and then we have a couple of workshops for your Git. So last question before you guys leave, can you write it in chat? Do your organization uses Git or any CI/CD? So the next thing is basically, so for your source code maintenance, do your organization use Git? And then do also you use any DevOps like CI/CD things for your embedded projects? If no planning and you need support, you can write to us. Once again, thank you all, and then please please subscribe to our LinkedIn, FiTech India. I think FiTech India link also, I think my team would have given.
Yeah. Thank you also, sir.
Yeah.
We added that in the chat. Before wrapping up, I just want to give a few, some information. Every year we are launching 2 new products and also 2 BSP launches for every product what we have. And also we are coming with a lot of session in this Tech Talk series. Okay, as was mentioned regarding the Edge AI and more. Okay, and also we are adding the highlights of the sessions in our YouTube channel. Please follow us on LinkedIn and YouTube to get the latest updates. You can find those links in the chart.
So help us to reach more of your team members. And then like if any services we can help, it would be a pleasure. So we have a huge team for engineering where we can help our partners to build their embedded products. Thank you all. Really, we can wrap up. Any questions you want to open, I think most of the questions they are put on the chat. And
yeah. And one more thing, anyway, we are sharing the feedback form to an email. Please help us with the feedback, and also you can add in case if you need any the particular session in the Tech Talk series, share your thoughts in that.
so please leave your requests. So we will process those requests and then come up with a couple of, like, say, I can see that like a couple of guys are asking, how can we create OS image for a SBC custom image and all. So you put this so that like we can see that those topics we can put it in a technical session, hands-on session. Thank you all.
Yes, sir, we can wind up. Yeah, thank you, everyone.
Yeah. Srini, just keep the meeting a little bit live so that other people, if they are putting some questions later on, you can. switch off. You can, I think, turn off the recording and then like maybe like you can.
Yep. Yeah.
uh, the chat will be accessible to them for some more time.
Sure, sir. Yeah.
Thank you.
Thank you everyone for actively participating in this session. And a sincere thanks to our speaker, Vasu sir, for giving a lot of insights. Yeah, you can add your comments in the chat.